Welcome back to part 3 of our Unity interview question answer series, where we covering over 100 plus real interview question across multiple parts. This series cover interview question ranging from beginner to advanced level. If you missed part 1 and part 2, make sure to check it out first. And hey, if I miss any question that you have faced in interview or think should be included in this video, let me know in the comment. I would love to add in the future video. This is part 3. Let's get into it. What is the purpose of rigid body component in Unity? The rigid body component in Unity enables a game object to be controlled by Unity's physics engine. It gives object mass, gravity, and collision response, making them behave realistically. With rigid body, you can enable the object to be affected by the gravity, allow the game object to collide with other objects that have colliders, allows applying force and torque to the game object to control its movement and rotation using methods like add force and torque. Rigid body is the key to creating physics-based dynamic gameplay. Let's move to the next question. What is the difference between static, kinematic, and dynamic rigid bodies in Unity? When you are dealing with the rigid body 2D, there are three key body types which determines how a game object moves and reacts to collisions. There are three types of rigid body in Unity: static, kinematic, and dynamic. Static rigid bodies are fixed and do not move or react to physics forces like gravity and collision. They are perfect for objects that are part of environments such as a wall, floors, and platforms. Static rigid bodies are super efficient because the physics engine knows they will never change. Kinematic rigid bodies. Kinematic rigid bodies are moved via code like move position, move rotation, rather than external forces. It means kinematic rigid bodies move only when you tell them through code. Kinematic rigid bodies does not react to force like gravity, but they can push other objects. Kinematic rigid bodies are ideal for objects that need to be controlled custom movement, but still need to detect collision, like player control characters or moving doors. Kinematic rigid bodies takes more processing than static rigid bodies because it requires manual movement updates but less than the dynamic bodies. Dynamic rigid bodies. Dynamic rigid bodies are fully simulated by the physics engine, affected by the force like gravity and collision, and interact with all other body types. Best for anything that needs realistic physics behavior like balls, crate, or ragdolls. Dynamic rigid body is most computationally expensive as it involves complex physics calculation for force, collision, and velocity. Choosing the right rigid body type is all about balance, performance versus realism. Let's move to the next question. What is the purpose of canvas component in Unity's UI system? User interface is a key part of nearly every game. From main menus and health bar to button and tooltip, UI elements help players to interact with your game in clear and meaningful ways. The canvas is the area that all UI elements should be inside. The canvas is a game object with a canvas component on it, and all UI elements must be children of such a canvas. When you create a UI object like button or text, Unity automatically creates a canvas if one does not exist. Canvas scaler and graphic raycast are the two other components that are associated with the canvas component. Canvas is a rect transform control instead of standard transform. UI elements use rect transform component, which is controlled by the canvas and allows for a snapping to screen edges and maintaining position to relate to the screen. The canvas area is shown as a rectangle in scene view. This makes it easy to position UI elements without needing to have game view visible at all times. The canvas also manages how the UI scales with the different screen resolution and handle user interaction through the integrated event system. Canvas uses the event system which detects and processes the player interaction with the elements, such as a click or hovers. UI elements in the canvas are drawn in the same order they are appear in the hierarchy. The first child is drawn first, the second child next, and so on. If two UI elements are overlapped, the later one will appear on the top of the earlier one. To change which element appear on the top of the other elements, simply reorder the element in the hierarchy by dragging them. The canvas has three main render modes that control how and where your UI appear, which will be covered in the next question. Let's move to the next question. What are canvas render mode properties in Unity? Canvas render modes determine how a canvas is positioned and displayed within a scene. Canvas render mode have three modes: screen space overlay, screen space camera, and wall space. Screen space overlay. Screen space overlay render UI on the top of the entire scene. If the screen is resized or change resolution, the canvas will automatically change size to match this. Next is screen space camera. This is similar to the screen space overlay, but in this render mode, the canvas placed at a certain distance away in front of the specified camera. The UI elements are rendered by this camera, which means that the camera settings affect the appearance of the UI. If the camera is set to perspective, the UI element will be rendered with the perspective, and the amount of perspective distortion can be controlled by the camera field of view. If the screen is resized, change resolution, or the camera frustum changes, the canvas will automatically change the size to match as well. The next render mode is wall space. In wall space render mode, the canvas will behave as any other object in the scene and can be moved or manipulated. The size of the canvas can be set manually using its rect transform, and UI elements will be rendered in front or behind of other objects in the scene based on the placement. This is useful for the UI that are meant to be part of the world. Choosing the right render mode ensures your game's interface look and behave exactly how you want, whether it's pure HUD or fully integrated into 3D world. Let's move to the next question. What is the canvas scalar component in Unity? The canvas scalar component is used for controlling the overall scale and the pixel density of UI element in the canvas. This scaling affects everything under the canvas, including font size and the image borders. Here, we have a UI scale mode which has three options: constant pixel size, scale with screen size, and constant physical size. The first one is constant pixel size. Constant pixel size is the one that is usually set as a default. This references the current pixel size of the UI elements. If the screen resolution changes, the UI element will ignore scaling. It keeps its pixel size regardless of the screen's resolution. Next is a scale with the screen size. Scale with screen size scales the UI element according to the screen size. So, if you want to build a game at 6:9 aspect ratio, you need to set your canvas reference resolution to something like this. When the screen size changes, so does the image. Most developers use this. Next is constant physical size. Constant physical size is basically the exact same as a constant pixel size. Expect this one makes UI element retain the same physical size regardless of the screen size. Using the constant physical size mode, position, size of UI elements are specified in physical units such as millimeters and point. Canvas scaler ensure your menus, button, and text look consistent and sharp on every device and resolution. Let's move to the next question. Which is better to use, a single canvas or multiple canvas in Unity UI? The basic component of Unity UI is the canvas. It generates meshes that represent UI element placed on it. Regenerate the meshes when UI element change and issue a draw call to GPU so that UI is actually displayed. Generating those meshes can be quite expensive, so do this as few times as possible. We only wanted to do it when something changed. The problem is some change means when one or more things on your canvas are updated or changed. Many people build their entire game's UI on one single with thousands and thousands elements. They change one text property and suddenly they have a high spike. So it's good thing to split up your canvas. Each canvas is an island that isolates its element from those of the other canvas. Take advantage of Unity's ability to support multiple canvas by slicing up your canvas to solve the batching problem with Unity UI. In simple words, everything under a canvas gets repainted when any element on the canvas is changed. Suppose you have a bunch of static UI on a canvas and a health bar that tracks the player health. When the player's health changes, Unity repaints the health bar and all other static UI that did not even change. This can cause frame rate drops once you start having a ton of UI. So, there is a benefit in grouping your canvas by static versus dynamic element. For anything beyond a very simple interface, multiple canvases grouped by update frequency gives you smoother performance and fewer draw call spikes compared to a single giant canvas. Let's go to the next question. What is a prefab in Unity and how is it used? A prefab in Unity is a reusable game object template with predefined components and properties. Think of it as a blueprint. You can save in the project window and reuse across multiple scenes or even projects. Prefabs are ideal for objects that you will use many times, like enemies, platforms, or power-ups. A major benefit to prefab is that all instance stays linked to the original prefab. It means the change that made or applied to the original prefab will affect all other instances. This makes fixing object errors, swapping out arts, or making other stylistic change very efficient. It saves a lots of time. Creating a prefab is simple. Just drag a game object from hierarchy into the project window. Prefab look quite similar to the other objects that appear in the project window. However, when selected, their type will be .prefab. Prefabs are represented with the blue text and a blue cube when it is present in the hierarchy. When you convert an object to a prefab, a new set of buttons is added above the transform component. As you can see, these are these buttons. The open button will open the prefab in hierarchy and let you make change on it. This change will also reflect on the original prefab. The select button. The select button highlights the original prefab in the project folder. Here, the override drop down. It will show all the changes that have been made to the prefab. At the bottom of the drop down, you will see two buttons, Revert All and Apply All. Revert All will revert all the changes in the override list, and Apply All button takes all the changes made to the selected prefab and applies them to all other existing instances, as well as the original prefab in the project window. Prefabs make complex and consistent world efficient and highly maintainable. Let's move to the next question. What are the advantage and disadvantage of using prefab in Unity? Prefab brings a huge benefit to Unity project, but they also have some trade-off. Some advantage that prefab offer, like reusability. You can create an object once, like an enemy, building, an item, and to use it across multiple scenes or locations. It will save development time and reduce redundancy. Other advantage is consistency. All the instances share the same configuration, so update to the source prefab and instantly update every copy. Prefab also offering runtime spanning. You can span prefab at runtime like bullet, enemies, and power-up using the instantiate method. Unity also supports prefab within prefab called nested prefab, which allows for more modular and maintainable design. Let's talk about some disadvantages that prefab have. As we know, making changes to the prefab automatically update all the instances, but overreason can lead making it difficult to introduce variation if many instances need slight modification. Another disadvantage is performance overhead. Prefabs can be performance overhead if misused. Rapidly instantiation and destroying large number of prefab frequently will lead to performance issues such as garbage collection spikes. Prefab can be used wisely. Prefab are one of the Unity's most powerful tools for efficient and scalable game development. Let's go to the next question. Name a few Unity packages on the asset store that you know. What is it used for? Unity packages are collection of assets, scripts, shader, and tools that you can import into your project to add specific functionality or features. Here are the few Unity packages on the asset store that everyone should know. First one is TextMesh Pro. TextMesh Pro provides an advanced text rendering and formatting tools, offering more control and flexibility over Unity's built-in text component. The second one is DoTween. DoTween is a fast, efficient, and easy-to-use animation engine for Unity. It allows developers to create smooth and complex animation with simplified code. Next is the CineMachine. CineMachine is a powerful, modular, and codeless camera system for Unity that enables developers to create dynamic and sophisticated camera behavior without writing extensive code. Next is FinalIK. FinalIK is a universe kinematic solution for Unity, helping developers to implement realistic character animation by simulating the movement of bones in a skeletal hierarchy. Next is a Playmaker. Playmaker is a visual scripting tool that allows game designer and developer to create gameplay mechanics and logic without writing traditional programming code. Next is a EasySave. EasySave is a serialization and data storage solution for Unity. It simplifies the process of saving and loading game data, including the player preferences and game progress. These packages can speed up the development and add professional touch to any Unity project. Let's move to the next question. How many ways can you import package into Unity? There are four main ways to bring a package into a Unity project. First one is import from Unity Asset Store. Open the Asset Store in the Unity editor or on the web. Add a package to My Assets, then click on Open in Unity to download or import through a package manager. The second way is to import a Unity package file from local. If you have a local.unity package from another project or third party, go to Asset, Import Package, Custom Package and select the file and import it. The next way to import a package is by using Unity Package Manager. This way is useful when you are importing a Unity official package like Cinemachine, TextMesh Pro or custom Unity package via Git or local folder. First of all, open Unity Package Manager by clicking on the window and selecting Package Manager. It will open a package manager like this. For Unity official packages, select Unity Registry from drop down at the top left corner. It will show all Unity's official package you can use. Find the package you want to use and click on the install. For Git or local packages, click on the plus icon at the top left corner. There will be option that will let you add package from a disk, Git, UR, tarball file, or you can find package by name. There is also another way of import package by drag and drop. Simply drag a .unity package file directly into your project window and Unity will prompt you to import. By all this way, you can import a Unity package into your Unity project. Let's move to the next question. How do you handle physics in Unity? Unity uses PhysicsX for 3D and Box 2D for 2D, giving you a powerful built-in physics engine. For working with the physics in Unity, we must have this physics component. The first one is Rigidbody. Rigidbody and Rigidbody 2D are essential for physics-based motion. Adding a rigid body on a game object will allow the object to be influenced by gravity, force, collision, and other factors. Rigid body has offered many key settings that will be held for physics-based motion. Another physics component is colliders. Collider defines the step of an object for collision detection. Unity has many types of collider that will help for physics. For a game object to have a physics interaction, the game object must have a collider and rigid body. You can use it as per your requirements. Apart from this component, Unity have collision and trigger event. It will let you respond to the physics event using special function like on collision enter, on collision exit, and their 2D version. If you are using triggers, use on trigger enter and on trigger exit. These events fire when objects collide or overlap, perfect for a thing like damage zone or pickup. If you want to move something physically, apply force using add force. You can also use raycasting to shoot invisible line into the scene to detect objects, ideal for line of sight, shooting mechanics, or checking the ground. For physics in Unity, there are some best practices you should remember. Always use fixed update for physics. Avoid manipulating transform.position directly on physics objects. It bypasses the physics engine. Use interpolation for smoother movement. Use collision layer and layer mask to optimize and control what interact with what. There is another thing that will be used in this physics. That is a physics material. Need your object to slide or bounce? Use physics material. Assign them to your colliders to control friction and bounciness in both 2D and 3D. And finally, for debugging, turn on the physics debug in Gizmos menu. You can also adjust global physics setting in project setting under the physics or physics 2D. With this tool, Unity's physics system can create everything from simple collision to complex and realistic interactions. Let's move to the next question. What is the use of layer collision matrix in Unity? The layer collision matrix lets you choose which physics layer can collide with each other. You can find it under Edit, Project Setting, Physics for 2D and Physics 2D for 2D. Layer collision matrix controls which layers can interact or collide with each other. Suppose you want to prevent friendly fire from occurring. You have two players with the layers player 1 and player 2. For each new layer, a new column and row added in the collision matrix. If you uncheck their box in the matrix, they will no longer collide. Layer collision matrix is super useful for ignoring collision between things like player and their own blades, enemy passing through each other, triggers that should not block movement. This simple grid gives you a fine control over collision and can improve your performance by avoiding unnecessary physics check. Let's move to the next question. What is the purpose of layer and tags in Unity? Tags and layers are Unity's way to organize and control game objects. A tag is a reference word which you can assign to one or more game objects. For example, you might define player tags for player control characters and enemy tag for non-controlled characters. You can use any word you want to as tag. A game object can have only one tag, and you can check it to script with command like compare tag. The editor includes untag, respawn, finish, editor only, main camera, player, and game control, which are built-in tags that don't appear in the tag manager. Layers are a useful feature provided by Unity, which are widely used to render a part of the scene by camera and by lighting to illuminate only part of the scene. Layers also help in ignoring collision between the game objects. You can assign a layer to game object by selecting the game object in the hierarchy. Then go to the inspector window and clicking on the layer option. Select the layer name you want to apply. You can put object on a specific layer to control which cameras render them using camera's culling mask. Limit which light affect them. Fine-tune collision using layer collision matrix. In short, tags help you to identify objects in script, while layers help you to manage how the objects are drawn, lit, and collide in the scene. Let's move to the next question. What is the purpose of the Animator Controller in Unity? Animator Controller in Unity is an asset that controls the flow of animation in a game object. Think of it as a visual state machine, where you define how one animation transitions into another based on the logic and parameters. Animator Controller is used to arrange and maintain a set of animation clip and associate animation transition for an animated game object. Assign the controller to the game object's animator component and it becomes the brain, controlling how and when the animation plays. Animator control are most often used with the characters, enemies, NPCs, UI element, and anything that else need a sequence of animation or reaction to input, trigger, or events. You can create an animator controller in Unity by clicking the right click on the project window. Select Create and choose Animator Controller. You can assign an animator controller by selecting the game object. Add an animator component and drag this animator controller into the controller field of the animator component. Animator controllers are built around several key concepts like state, substate machine, transition, and parameters. States are building block of animator controllers. Each state typically represents an animation clip. It means you have states like idle, walk, run, jump, attack, and many more. When an object is animated, it always be in one of these states. You place the animation assigned to the current state until it's told to transition to another state. Transitions are one of the important concepts in Animator. Transition define how and when Unity moves from one state to another. With the help of transition, you can define the condition under which a transition should occur. As an example, you define the speed parameter is greater than 0.5. It means transitions allow you to control flow of animation based on the gameplay input or logic. We have talked about the parameter speed in transition. Parameters are variables used to control transition. Parameters are defined inside the Animator Controller and can have different types like integer, float, bool, and triggers. This parameter can update to script or animation event. Suppose your player presses the jump button. You can set is jumping to true, which would trigger a transition from idle or run to the jump animation. Another important concept is substate machine. A substate machine is a container of states. It's useful for organizing large animator controllers into modular sections. You could have one state machine for locomotion and another for combat. Substate machine keeps your animator clean and manageable. Character animation, enemy AI, UI animation, and environmental effects are common scenarios where animator control can be used. Animator controls are one of the Unity's most powerful features for managing animation logic. With their state machine structure, parameter-based transition, and substate machine, they provide high flexible system to control how your game objects animate and respond to the world. Let's move to the next question. What is the difference between animation and animator component in Unity? In Unity, animation and animator refer to different components and system used for bringing movement to game objects, but they are not same thing. The animation component is older legacy system in Unity, whilst the animator component is newer and more powerful animation system in Unity. The animation component lives with the individual animation clip. On the other hand, the animator controller is visual state machine that manage multiple animation clips. In animation component, animations are directly controlled through scripting, where you can use methods like play or crossfade to trigger specific clip. The animator control defines the animation state and the transition between this state based on the parameter you set. The animation component is simple for basic, isolated animation, but lack of the advanced feature for managing complex character animation and transitions. The Animator system provides a more robust feature for character animation, blending, retargeting, and complex state management, making it preferred choice for most modern Unity projects. For anything beyond very basic motion, the Animator system is today's preferred choice. That's wrap for part 3. If this video helped you, hit like button, subscribe, and turn on the notification so you don't miss the next part. And don't forget to drop your own interview question in the comments. I will try to feature them in the next part. If you enjoyed this video and want to support the channel, feel free to buy me a coffee at the link in the description. Thanks for watching. I will see you in the next part.